DIKWP, 小攻 abor. Your learning journey starts now. Ever felt that nagging gap between verifying a solution and actually finding it? That's the heart of P equals no problem. We've wrestled with Turing machines and no problem completeness for decades. But what if the real bottleneck isn't just computational grunt, but something deeper? What if the problem lies in the very structure of meaning itself? Let's dive into a new perspective. Alright, let's talk DIKWP. Think of it as the cognitive ladder: data, information, knowledge, wisdom, purpose. It's not just a neat pyramid, it's a dynamic network. Real-world problem solving isn't a rigid Turing tape, it's this layered dance. Take AlphaFold cracking protein folding, a no-problem nightmare with 10 to the power of 300 possibilities. Brute force? Forget it. But AlphaFold used biological semantics, patterns learned from data, to leapfrog the search. This hints at semantic computability, solving problems by understanding their meaning across layers, not just symbol shuffling. The old view focuses on steps, the new view asks, how many meaning jumps are needed? So, how do we measure this semantic difficulty? Two new metrics: semantic compression ratio and semantic jump cost. Think of compression. P problems often have elegant, compressible solutions, sort algorithms, for example. No problem problems? Their solutions often resist compression, looking like random noise. Then there's jump cost. Solving P is usually smooth sailing within one or two semantic layers. No problem problems. They demand high-dimensional semantic leaps, switching perspectives, introducing new concepts mid-solve. Maybe the core of no-problem hardness isn't just size, but this inherent semantic fragmentation. It's not just about computation time, it's about the cognitive cost of bridging meaning gaps. Now, can we build systems that handle these semantic jumps better? Enter the consciousness calculation model. Imagine computation guided by intent, like a global workspace integrating information. Think of it as an oracle, but instead of magic, it's structured semantic insight. Could such a model, leveraging purpose-driven feedback loops, navigate the complex semantic fields of no-problem problems more efficiently? This isn't claiming non-Turing computation in the strictest sense, but rather exploring computation augmented by meaning, potentially breaking the perceived limitations of pure formalism. It's about building machines that don't just calculate, but understand and adapt. This journey takes us beyond algorithms. Gödel showed formal systems have limits, truths escaping their logic. Could this be a semantic self-reference issue? Human consciousness seems to constantly transcend its own frameworks. Free will itself might be rooted in this non-algorithmic choice-making, bridging intent and action. Perhaps the ultimate quest isn't just solving P equals no problem, but understanding the fundamental role of meaning in computation. The universe itself might be a grand semantic compressor. So, the next time you face an intractable problem, remember, maybe the solution isn't just out there, but requires a different kind of thinking, a different layer of meaning. The search continues.